section 1.2, day 1 of limits, looking at it from a graphical and numerical approach. We're going to define limits and then also look at when limits fail to exist. And I know this is a little bit of a review topic because we do cover this in pre-calc, but let's just kind of go through what does it mean to find a limit and what exactly is going on here. So when you're finding limits, we can ask ourselves, really, what is happening to the y value as x gets close to some certain number? So we're trying to find, basically a y value, an output number. What is it approaching for height as we approach some horizontal value, c, let's say. So if I had some sort of graph and this were my graph there, my function, when I approach c, so as x comes into c, either from the left side or perhaps, we're coming from the top side, from the right as we approach C, what value do I see happening on my y-axis? So really, when we find a limit, we're really coming up with this y value. So in order for a limit to exist, the two things have to be true. And I'll remove this. It says the limit as x approaches C of my function f of x is equal to looking at it from two perspectives. The limit as x approaches c of the function equals some number L if and only if as I approach x, as x approaches c from the right, I get that value L, and as x approaches c from the left, I get that value of L. So we have to have this happening where I'm coming in to C from the left side and I get this value, let's call it L. And as I come in from the right side of C, I also get this value of L. Then we have a limit that exists. So left side, right side, it becomes very, very important in order for a limit to exist. So just look at these three graphs. The limit as x approaches 1 of the function is equal to what? So as I approach 1, so I'm coming into 1 from the left side and the right side. So I'm going to track up here to 1, and I find that there's a hole, which means that there isn't an exact value. When x is equal to 1, y is equal to, well, I don't know here. But that's when I look at f of 1. I get, I don't know. But if I look at it from a limit perspective, it's saying, what does it approach? Well, as I approach 1 from the left and 1 from the right, it appears that from the left side and from the right side, I'm getting to this height equal to 2. So I would say this has a limit of 2. The next picture. As I approach 1 from the left side, I would be traveling up my graph, and here I'm coming into 1 from the right. So if I draw a vertical line at 1, I'm coming in from the right side. Here's my graph. I'm coming in and approaching this height. Almost 2, isn't it? As I come in from the right side, let's choose a different color. As I come in from the right side, I'm traveling down my graph, and it too is coming in at a height of 2. So I have a limit of 2. Now what's interesting on this one is I have this dot existing right down there. Well, that's just telling me when I have f of 1, the actual y value in this function is 2. Or, I'm sorry, is 1. It's a height of 1. But if I look at it from a limit perspective of this function g of x, the limit as I approach 1 is actually 2. We have that jump discontinuity that we talked about last year in pre-calc. Here's the function that's going on, and you can see x is not defined when I'm at 1 for this part of the function. But then here, when g of x equals 1, when x is equal to 1, my y value becomes 1. So g of x is equal to 1 when I put in 1 for x. Next one, c of x, or h of x. We have this function h of x. It looks like it's a nice linear function. I travel up at 1, and I actually have the value of 2. So when I put in, let's see, we got an h function. H of 1, I get out 2. But what is the limit as x approaches 1 of this function h of x? Well, the limit as we approach 1, as I come in following my graph, I notice it too has a height of 2. So everything agrees there. This is a nice continuous function, isn't it? There's no gaps, no jumps, no breaks. This one, I have what we would call a jump. Why am I spelling jump with a G? A jump discontinuity. And on this one, we refer to that as a hole discontinuity, if you recall from pre-calc. So the value from the left side must equal the value from the right side in order for limits to exist. Why should we study limits? Well, limits are very useful to describe continuity, and we will be doing that in chapter 1. It also is used as the definition, the driving force behind what is a derivative and what is an integral, which are very key phrases, concepts in calculus that we're very interested in. Sorry about that. And they provide the foundation of calculus. So limits are very important. Graphical approach to limits. You know, if you think you can do this on your own, why don't you go ahead and pause this, fill in the notes, and then come back and let's see how you did. So I'll hit pause. Okay, I went ahead and wrote in my answers. Do a quick comparison, maybe hit pause again and do a quick comparison to see if everything agrees. If not, let's ask some questions in class tomorrow. Maybe take a highlighter and just highlight something that you need to ask. But I'll go through, maybe I'll go through this middle one and just talk about my reasonings and rationale behind my answers. So this first question is purely asking, what is the function when I'm at -3? So when x is equal to -3, what is the y value? So when I'm at -3, I can see I've got a solid dot here, and that is at a height of 1. So that was my answer. When I put in -3, I get out 1 for a y value. The next questions are limits from left side and right side. There's a plus sign here and a minus sign there, meaning from the right and from the left. And so when I approach -3 from the right side, I notice that I'm coming up to this height of 1, 2, 3. So it has a height of 3. When I come into -3 from the left side of -3, that means I'm traveling kind of along this graph. It too has a height of 3. So if the right limit and the left limit are 3, the limit exists. Remember that this symbol here means therefore. That might be a new symbol to some of you. This means therefore in math. So I'm kind of creating a conversation here in this box. The limit as x approaches -3 from the right side is, this means is 3. The limit as x approaches -3 from the left side of the function f of x is equal to 3. Therefore, since the left and the right agree, I can say the limit as x approaches -3 is 3. These two both must be 3 in order to answer that the limit is 3. So on this side, we can say, hey, you know what? The limit from the left and the right agreed, and we get 3. On this one, we notice from the right side, we were at -1. From the left side, we were -1. Therefore, very important, the limit does exist as x approached to 0. So the left side and the right side were equal. This last one, however, you'll notice that the limit did not agree. From the right side, I was at 2. From the left side of 1, I was at -1. And that produces a limit that does not exist. The left side and the right side didn't exist. And that's what, I put these hands on here. We got the left-hand side and the right-hand side, and they didn't exist because left doesn't equal right. And that, what we were approaching 1. From the left side, we were down here at a height of -1. From the right side, we were up here at 2. And you get that jump discontinuity going on, and the limit didn't exist. Okay, so more graphical work here. And just wanted to see where we're at. Graphical approach. So this is out of our book, exercises 21 and 22, and let's identify values of c for which the limit exists. So let c be -3 here. As x approaches -3, does a limit exist? Well, first I'm going to find where -3 is. First thing I notice is I've got this gap going on, right? That's probably a good indication the limit does not exist. From the left side of 3, so the limit as x approaches -3 from the left of f of x, it's equal to 0. And the limit as x approaches -3 from the right side of this function f of x, well, that's equal to this height of, what is that, a height of 2, isn't it? And I noticed that from the right side and from the left side, the numbers do not agree. The heights are different. This is a does not exist limit. Overall, at -3, we don't have a limit that exists. Let's look at the next one. As we approach -1, so as I approach -1 from the left and -1 from the right, they're in agreement. The value is 2. Let's move on. Let's look at our graph as x approaches 2. So I'm over here at 2. I notice there's a little bit of funky stuff going on here. So, I'm going to be really careful when I'm doing this limit. So as I approach 2 from the left, I'm traveling along this graph here and I'm getting closer and closer to 2. And its height is 2, isn't it? So I'm getting a 2 from this side. Then as I come into 2 from the right side, I'm traveling along, I'm getting closer and closer as x approaches 2. Its height is also 2, so it's got a limit of 2. Now, don't get confused. The actual value of f of 2 is 1, isn't it? This means something completely different than that. This asks, when I put in x, I get out what value for y? I get out 1. This says, as I approach 2, I get out 2. Okay, and the final one says, what about if we approach 4? If we're approaching 4 from the left and from the right, I'm going to just jot this down. As I approach 4 from the left, what do I get? And as I approach 4 from the right, what do I get? So the limit of f of x from the left and the right. Well, here, as I come in from the left side of 4, I'm about in there. That looks like a height of 1. As I approach 4 from the right side, I'm traveling along this function. It too has a height of 1. So I have a limit that exists because the left side and the right side are in agreement. It is 1. Now, why don't you hit pause real quick and run. Okay, I'm back with you. Looking at this, those are my answers. How do we agree? Do we agree? If not, why don't you put a question mark by one that you got wrong if you want to ask in class tomorrow. Let's just kind of zone into this one. This one's just kind of a unique one. It says, as we approach -2, so here's my value at -2, isn't it? X is -2. I have a dot, which means that f of -2 is indeed equal to -2. Looks like it has a height of -2. But the thing that I'm concerned about is as I approach -2 from the left, while I'm traveling along this side of my graph, which really doesn't come into anything. I really feel like this is one of those that just continues downward. And as I approach -2 from the right side, I go over on the right side of -2, and it too is heading to negative infinity. There isn't agreement. I would say this does not exist. There is not a value number that it stops at. Okay, so numerical approach. We can use our calculators to get some values on this, and why don't you load this into your calculator, and so go into your y equals and load up this function. And then what I want you to do is get values for this. Okay. Okay, I'm going to show you how I load this, and I would like you to get used to this. It is a rational function. We need a fraction really on this. One of the quickest ways on your TI-84, if you have this newer software, if you don't, let's update your software, but hit alpha and the y equals key. It brings up this nice quick sub menu where I can grab fractions. If you need to replay it, replay it. I need x squared minus 3x and then a plus 2. Got it. To move downward, I'm just going to use my arrow key and bop me down to the bottom and get x minus 2. It is now loaded, and I can go into, I'm going to go into table set, and I want to put this to ask, and mine is actually sent to ask. I don't know if you've used this very often, but it's a quick way to get values. So I'm taking my table set into ask and go into my table, and I can put these numbers in. 1.75, enter, gives me answer. 1.9, put it in, get an answer. And very, very quickly, I can fill in this chart. So why don't you go ahead and do that, and we'll come back. These are my values. Hopefully they agree with you. Hit pause, do a comparison. Why does this not exist as we come into 2? This limit as we approach 2 has some values on either side that are interesting. And the trend is that this thing is headed to 1, and the trend is this is coming down to a height of 1. This actually has an answer then of 1. But when I look at f of 2, I get a does not exist, don't I? If you tried to plug that in, you probably got an error message. And one of the reasons is we can actually factor this x minus 2 and an x minus 1 over this x minus 2. And, you know, we get this canceling away. And if you recall from last year, that would indicate that we have a whole discontinuity at x equals 2, but that does not mean that the limit doesn't exist. It actually graphs out very nicely. So there you go. Finally, this one has the chart filled out for you. I would like you to run through, answer these questions, and then come back and see if you agree with mine. So I'm going to put you on pause, write the answers. You do the same. Pause it, write your answers, and let's see if we agree. Okay, there are my answers. If you have some questions, we can start here tomorrow in class, do just a quick review, and I'll be looking for your notes to be completed, and we'll do homework in class. So have a great day.